Hello again, Algebra 1 students. We're back in week 2 of Unit 3 Family Functions Syllabus. We are in Tier 2, Lesson 2. Let's check off our booklet. And here we are in Lesson 2, Domain and Range, Minimums and Maximums of Absolute Value. So if you recall this from Tier 1, this f of x equals the absolute value of x. This is also the table from Tier 1. This is what is known as the parent function. And basically all that means is this is the function that all other absolute value functions are built off of. That's why you see this with other operations happening, like in the first tier that we looked at, there were like additions and subtractions after the absolute value expression. And then we'll also see some examples where there's additions and subtractions on the inside and things like that. And I'm just going to graph the table real quick. And this is something that it's a good idea to have memorized when you're working with absolute values. Okay, so now our parent function is graphed. As we look at this, there is a couple different ways to look at it and think of a max. When you're thinking about mins and maxes, you're thinking about the lowest value that a graph reaches on the Cartesian plane. So in this case, this graph goes from here on the bottom of it and then goes all the way up. So technically we don't have a point for our max, so we could say that our max is infinity, or if you wanted to say none, because technically, again, we don't have a point for our max. However, we do have a point for our minimum, and it's the vertex right there. So if we know that the vertex of the parent function, if you remember from Tier 1, was 0, 0, and if you don't remember, you can look right here and count it off and see that it's at the origin, which is 0, 0. Then you know that your min for the parent function is also 0, 0, or some people just write the min as 0 using the y value, which is the up and down. Now, let's think about the domain and range for the parent function. Let me erase this out. There we go. So our domain, remember, is all our x values. Well, this graph goes on forever this way and goes on forever this way. So it literally is going to touch every single x value. Smallest x value that we know is negative infinity, and it will eventually touch negative infinity going this way. And then the largest x value that we know is positive infinity, and it will eventually touch positive infinity going that way. So our domain for our absolute value continuous function is negative infinity to positive infinity. Range is a little different. Remember, we read range from bottom up. So as of right now, there's no y values on this graph. But once we hit 0 at the origin, we now have our very first y value. And our very first y value is 0, because it's the y value at the origin. Okay, and then it goes on, and this graph will go up forever, both ways, but it'll go up forever. So we know that the range will have the possibility of having infinity in it as well, because it will go on forever. Let's look at another example. Now this one, we're going to have to plot our points a little bit, so let's do that quickly together. I always like to start in the middle. If I plug in -2, I get -2 plus 2, which is 0. The absolute value of 0 is 0, plus 1 is 1. So if I put in -2, I get out 1. And if I put in -1, I get -1 plus 2, which gives me 1. The absolute value of 1 is 1, plus 1 is 2. If I put in 0, I get 0 plus 2, which is 2. The absolute value of 2 is 2, plus 1, which is 3. If I put in -3, I get -3 plus 2, which is -1. The absolute value of -1 is 1, plus 1, which is 2. If I put in -4, I get -4 plus 2, which is -2. The absolute value of -2 is 2 plus 1, which is 3. So I can graph this. -4, 3 about there, -3, 2 about there, and -1, 2, and then 3, 0, 3, which is right there. So I can now draw this, sketch it in. And now let's look at characteristics. So again, my max, I would take either infinity or none, either one, just because, again, there's really no max, but the max number that we could get to would be infinity. Our minimum, again, is the vertex at the bottom of the V. Well, here our vertex, if we look, is 1, 2 back, so -2 back, and positive 1 up. So that's going to be our min and our vertex. Okay, and then now let's talk about our domain and range again. Well, remember, our range is our set of all values that are on the x-axis. Well, this graph goes on forever this way and goes on forever this way. So it will eventually touch every single x value. And how we denote that is negative infinity to positive infinity is going to be the domain. And the range is our y values. The y values start at the vertex. There are no y values below the vertex here. So the range starts reading bottom up, starts at positive 1, where the y value of the vertex, and then it goes on all the way to infinity. So taking a look at this, what did we notice about the differences between the parent function and the second function? Well, if you look at the parent function, we're at the origin. And if you look at the second function, we're left 2 and up 1 from the origin. Left 2 and up 1 is what I notice about the differences between the parent function and this function. And if you take a peek right here, the up part comes from this number on the outside of the absolute value function, and the left 2 part comes from the inside of the absolute value expression, and it's opposite of what you think. See how it's plus 2 in here, but we went left 2? That's because when it's inside, it moves left and right, and it's opposite of what you think. When it's outside, we move up and down, and it's exactly what you think. We'll work through this and struggle together. Good luck on your practice sets.